हेलो स्टूडेंट्स, वेलकम यू ऑल वंस अगेन ऑन बिहाफ ऑफ रेजोनेंस। आज हम 30 तारीख की सेकेंड शिफ्ट की मेमोरी बेस्ड केमिस्ट्री पेपर देख रहे हैं। चलो देखते हैं क्या क्वेश्चंस आया है आज। द फर्स्ट क्वेश्चन, ज्योमेट्री ऑफ डेका कार्बोनाइल डाईमैंगनीज इज, दैट इज हियर डेका कार्बोनाइल डाईमैंगनीज की shape will be like this. It is in octahedral shape. It is the dimer of MnCO5. So, the correct answer can be octahedral. Second question, which of the following species has square pyramidal geometry? PCl5, BRF5, PF5, nickel tetracyanide. PCl5, you know, it is having sp3 dehybridization with 5 bond pairs and 0 lone pair, and BRF5 has sp3 d2 hybridization with 5 bond pair and 1 lone pair. It has square pyramidal shape. And PF5, it is having sp3 dehybridization with a trigonal bipyramidal shape with a 5 bond pair and 0 lone pair. Nickel tetracyanide, it is dsp2 hybridized and square planar shape. So, the question once again, it has which has square pyramidal geometry. The question was which has square pyramidal geometry, then you can answer the square pyramidal geometry can be among the given species, that is PCl5, BRF5, PF5, nickel tetracyanide. Only BRF5 has square pyramidal geometry, and remaining are having PCl5 and PF5 has square trigonal bipyramidal geometry, and nickel tetracyanide has square planar geometry. So, answer is 1 on here, answer BRF5. Next, statement 1, hydrogen telluride is more acidic than hydrogen sulfide. Statement 2, hydrogen telluride has less bond strength than hydrogen sulfide. So, in the 16th group hydrides, that is from H2O, H2S, H2SE, hydrogen selenide, hydrogen telluride, from top to bottom, the HM bond length increases and bond strength decreases. So, the first statement here, hydrogen telluride is more acidic than H2S. Yes, from top to bottom, due to decrease in bond strength, it can easily give the H plus. So, hydrogen telluride is more acidic. And second statement, hydrogen telluride has less bond strength. Hydrogen telluride has less bond strength than H2S. Yes, it is also correct. So, here both the statements are correct. Next, among the following correct statement is, stability of hydrides order is given NH3 less than, PH3 less than, ASH3 less than, SBH3 less than, BiH3. In the 15th group hydrides, from top to bottom, as the atomic size of the element increases, the MH bond length increases and bond strength decreases. So, stability decreases, but here the given order is increasing order. So, this order is wrong, and the reducing strength order is increasing. Here NH3 less than, PH3 less than, ASH3 less than, SBH3 less than, BiH3. Yes, it is the correct reducing strength order of hydrides. Third statement, NH3 is the strongest reducing agent, while BiH3 is the mild reducing agent. ये भी गलत है, NH3 mild reducing agent and BiH3 is strong reducing agent. And basicity of hydrides order is given. Here NH3 less than, PH3 less than, ASH3 less than, SbH3 less than, ViH3. This order is also wrong. Here NH3 is a stronger base than BiH3. That means the basic strength order decreases instead of increasing. So, इस क्वेश्चन में the correct answer 2. Now, it is from electrochemistry. Given standard electrode potentials of BrO4 minus, IO4 minus and ClO4 minus are 1.85, 1.65 and 1.20 respectively. Then the correct order of oxidizing power. So, here from electrochemical series, you know, as the SRP values increases, oxidizing strength increases. So, greater the reduction potential, greater is the oxidizing strength. So, the correct order will be third one. Next, this is from chemical bonding. Since fluorine is more electronegative than nitrogen, the resultant dipole moment of NH3 is greater than that of NF3. Statement 2, in case of NH3, orbital dipole due to lone pair is in the same direction as the resultant dipole moment of NH bonds, whereas in NF3, the orbital dipole is in the direction opposite to the resultant dipole moment of 3 NF bonds. Here both the statements are correct, because here in NH3 and NF3 you can observe nitrogen is more electronegative than hydrogen. So, the bond moments are directed towards the lone pair, whereas in NF3 bond moments are directed towards NF bonds. So, as a result, the resultant dipole moment of NH3 here it is more than that of resultant dipole moment of NF3, because here there is two opposite directions. Here all the bond moments are in same direction. That is why the net dipole moment will be less than that of NH3. Next question, the mixture of, in a mixture of B and C, A is added, given moles of A, B and C are respectively Na, Nb and C, then determine mole fraction of C. Very simple question, that is number of moles of C upon total number of moles of 3 substances, that is Na plus Nb plus Nc. So, Nc upon Na plus Nb plus Nc is the answer. Next question, the color of KMnO4 and K2Cr2O7 is due to, that is due to DD transition and metal to ligand charge transfer, ligand to metal charge transfer, F centers. In KMnO4, Mn has +7 state and in K2Cr2O7 also chromium has +6 oxidation state. And in Mn +7 state there is no unpaired electron, Cr +6 state there is no unpaired electron. And you know, generally for showing color there should be unpaired electrons, then they can show DD transition. But in these cases the color is due to ligand to metal charge transfer. So, here ligands are oxide ions, ligand to metal charge transfer is taking place, that is why these are showing the purple color and orange red color. Next, this is also from D block, MnO2 plus KOH plus O2 gives X, and X and Y reaction, here the reaction between X and Y पूछा है, इसमें MnO2 KOH plus O2 से क्या बन रहा है, K2MnO4 बन रहा है. अब इसमें MnO4 -2 से MnO4 माइनस बनेगा। यहाँ ये रिएक्शन, ये एरो मिस हो गई, ये इलेक्ट्रोलाइटिक ऑक्सीडेशन है, इलेक्ट्रोलाइटिक ऑक्सीडेशन। इसमें MnO2 KOH से रिएक्ट होने से X बन रहा है, X इलेक्ट्रोलाइटिक ऑक्सीडेशन से Y बन रहा है। तो आपको ये पूछा है X एंड Y क्या होगा। सो MnO2 KOH और ऑक्सीजन के साथ K2MnO4 बनेगा, ये X कंपाउंड है एंड ये X कंपाउंड ऑन electrolytic oxidation it is giving KMnO4, that is K2MnO4 is converting into KMnO4. So here X is having MnO4 -2 ion, this is X, it is having MnO4 -2 ion, Y is having MnO4 minus, that is KMnO4, potassium permanganate is formed, and in this anion is MnO4 minus. So here answer is, here answer you can say X is MnO4 2 minus and Y is MnO4 minus. Next, this is also from D block. Chromyl chloride CrO2 Cl2 plus NaOH is giving X, X plus HCl plus H2O2 is giving Y. What are the X and Y? Here CrO2 Cl2 with NaOH gives Na2CrO4, sodium chromate, which is yellow colored compound, and this on acidification it gives dichromate, okay, sodium chromate to dichromate, sodium dichromate. Sodium dichromate in acid medium in presence of hydrogen peroxide converts to chromium peroxide, which is having butterfly structure. And here what are X and Y? CrO4 2 minus and CrO5 are Na2CrO4 and CrO5 are X and Y. So you have to identify from the options X and Y. अगला क्वेश्चन, which of the following solution have maximum depression in freezing point? यहाँ 180 ग्राम of glucose in water, 180 ग्राम of benzoic acid in benzene, 180 ग्राम of acetic acid in benzene, 180 ग्राम of acetic acid in water. So इसमें इन वाटर ग्लूकोज के लिए तो ग्लूकोज तो नॉन इलेक्ट्रोलाइट है, ये डिसोसिएशन और एसोसिएशन नहीं होगा। बेंजोइक एसिड बेंजीन में, बेंजोइक एसिड बेंजीन में एसोसिएशन होगा, एस्टिक एसिड भी बेंजीन में एसोसिएशन होगा, एस्टिक एसिड वाटर में डिसोसिएशन होगा। सो जहाँ डिसोसिएशन होता है वहाँ आई वैल्यू, वैन हाउस फैक्टर वैल्यू बढ़ेगा, नंबर ऑफ पार्टिकल्स बढ़ेगा, नंबर ऑफ पार्टिकल्स बढ़ेगा तो डेल्टा टी एफ इक्वल टू यू नो आई इंटू के एफ इंटू एम. So delta TF directly proportional to I into M. So as the I value increases, delta TF value increases. That's why here the answer can be acetic acid in water. Next, among the following how many are optically active? These are the complexes given. In this optical activity, you know, if there is no plane of symmetry, then that complex can be optically active. So in the given complexes, this cis COEN twice Cl2 is optically active, trans COEN twice Cl2 is optically inactive, and cis PTEN twice Cl2 plus 2 is optically active, trans PTEN twice Cl2 is also optically inactive, and PTEN thrice plus 4 is optically active, PTEN Cl4 is optically inactive. So number of optically active compounds, you can see there are 3 optically active compounds and 3 optically inactive. Next question, this is from atomic structure. In helium plus ion, an electron jumps from 5th excited state to 1st excited state, then total number of spectral lines formed are. So यहाँ 5th excited state मतलब it is 6th shell, 1st excited state means 2nd shell. So total spectral lines up to 5th state, 6 से 5th आएगा तो एक लाइन बनेगा, 6 से 4th के लिए तो 2 लाइन बनेगा, 6 से फिर 3rd के लिए 3 लाइन्स पॉसिबल है, सेकंड में 4 लाइन्स, सो टोटल आप गिनेंगे तो 10 लाइन्स आएगा. Or you can also calculate based on this formula, that is delta n into delta n plus 1 by 2. Delta n means change in the shell numbers, that is n values. 6 minus 2 4, 4 into 4 plus 1 by 2, then also you can get 10. Next, using following reaction, 2 Fe plus O2 gives Fe2O3, C plus O2 gives CO and C plus half O2 gives CO. अब इसमें ये रिएक्शन से आपको फाइनल रिएक्शन ये दिया है Fe2O3 प्लस 3C gives 2Fe प्लस 3CO. इस रिएक्शन की एंथैल्पी चेंज फाइंड करना है. सो ये एंथैल्पी चेंज ऑफ द रिएक्शन फाइंड करने के लिए ये दोनों रिएक्शन से ये टारगेट इक्वेशन को हम एंथैल्पी फाइंड करना है तो कैसे आएगा, इक्वेशन 2 को 3 से मल्टीप्लाई करेंगे और इक्वेशन 1 को सब्ट्रैक्ट करेंगे, देन यू विल गेट एंथैल्पी ऑफ द टारगेट रिएक्शन, दैट इज 492. Next question, how many of the following species can show redox disproportionation reaction? ये disproportionation show करने के लिए इसमें ये 3 different oxidation states में exist होना चाहिए वो एलिमेंट. हाइड्रोजन पेरोक्साइड में ये -1 ऑक्सीडेशन स्टेट है एंड फास्फोरस में ये 0 ऑक्सीडेशन स्टेट, NO2 में ये +4 ऑक्सीडेशन स्टेट एंड Cu प्लस ClO3 माइनस में ये +5 ऑक्सीडेशन स्टेट, ClO4 माइनस में +7 ऑक्सीडेशन स्टेट, ये 0, ये भी 0. अब इन सभी में 3 डिफरेंट ऑक्सीडेशन स्टेट्स में एग्जिस्ट होने की चांसेस किसकी है, हाइड्रोजन पेरोक्साइड में ऑक्सीजन -1 स्टेट में ये -2 और 0 दोनों में एग्जिस्ट हो सकता है. फास्फोरस 0 में है और ये लोअर ऑक्सीडेशन स्टेट और हायर ऑक्सीडेशन स्टेट दोनों में शो कर सकता है. और सिमिलरली NO2 में ये लोअर ऑक्सीडेशन स्टेट और हायर ऑक्सीडेशन स्टेट दोनों में शो कर सकता है. Cu प्लस में ये +1 स्टेट में +2 और 0 दोनों में शो कर सकता है. ClO3 माइनस में क्लोरीन +5 में है, ये लोअर ऑक्सीडेशन स्टेट्स +3 भी शो कर सकता है, हायर ऑक्सीडेशन स्टेट +7 भी शो कर सकता है. और Cl2 0 में है, ये लोअर ऑक्सीडेशन स्टेट -1 और हायर ऑक्सीडेशन स्टेट्स +1 +3 +5 +7 में भी ये एग्जिस्ट हो सकता है. सो ये सारे स्पीसीज ये 3 डिफरेंट स्टेट्स में एग्जिस्ट हो सकता है, तो ये डिस्प्रपोर्शनेशन होगा. तो टोटल कितने स्पीसीज ये डिस्प्रपोर्शनेशन हो सकता है, 6. नेक्स्ट, हाउ मेनी ऑफ द फॉलोइंग कैन शो फ्लेम color test? In given species, you can see beryllium, magnesium, strontium, barium, lithium, copper. beryllium, magnesium को छोड़ के बाकी सब फ्लेम टेस्ट दे सकता है. beryllium, magnesium स्मॉलर साइज है, ये फ्लेम टेस्ट नहीं देगा. नो कलर इन द फ्लेम टेस्ट. नेक्स्ट, in buffer solution of benzoic acid and sodium benzoate, pH of the solution is given, then ratio of moles of salt to moles of acid is, pK of benzoic acid is given as 4.5 and log 2 is 0.3. Now from buffer solution Henderson's equation you can write pH equal to pKa plus log salt concentration upon acid concentration. pH is given as 4.5, pKa is 4.2, log salt concentration upon acid concentration, that equal to 0.3, log salt concentration upon acid concentration is equal to 2, and ratio of salts of moles of salt to moles of acid is also equal to 2. Okay, that's it student. इस पेपर में इतने क्वेश्चंस मिला है अपन को, और ये जो भी क्वेश्चंस आया है ये इजी टू मॉडरेट लेवल क्वेश्चंस है, और NCERT से डायरेक्ट लाइंस लेके क्वेश्चंस बन रहा है इनऑर्गेनिक से। फिजिकल केमिस्ट्री में तो सिंपल कैलकुलेशन वाले क्वेश्चंस ही मिल रहा है अभी तक। सो आगे जिसका भी एग्ज़ाम हो तो थोड़ा NCERT को रिवाइज करके जाओ, तब आप अच्छी तरह क्वेश्चंस आंसर कर सकते हैं। ओके स्टूडेंट्स, थैंक यू। Once again we will meet in the next paper.